Okay, we're going to get started, everyone. I am Grover Browning. I'm the program manager for automation at the GlobalNOC. I started in that role on May 20th, and it's now June 6th. What I'll be presenting today is an overview of our first project, as well as some training on how to use Jinja to create router configs. Really any configs or text files, but in this case, we're talking router and switch configs. Our whole initiative here on automation and driving our configurations with automation is really one of a kind of a GlobalNOC-wide directive. This will be kind of how we manage configurations going forward, or at least one of the ways we manage them. Just in the same way that we use two-factor to log on to equipment, and we use the Bastion servers to SSH2 before we get to the real routers or switches, we'll use automation to configure the equipment in most non-emergency situations. Just a quick note at the start, since I've got a captive audience here, folks are going to see GitHub and GitHub Enterprise account creation messages coming out to them. Don't be surprised when you see those. Feel free to look around. Know that if you press the merge pull button, you will be deploying a live change to the network, and you probably don't want to do that until we go through some training, so do not touch. I just want to get that out of the way at the start. So I want to give this sort of basic overview of where we're going with automation. Today, I think many of us are probably, at least in the GlobalNOC, aware of a tool we have called distool, in which you can create a text file of configuration commands and then have those pushed out to the network. You might create the text file on like one of the sandbox servers and then push it out via distool. This is very similar. The system that we're going to be moving to uses Ansible and GitHub Enterprise. It's very similar to the distool methodology, except instead of creating the text file on a sandbox server, you're going to edit it via a web GUI or a web interface, a GUI interface on the web. In GitHub Enterprise, and then Ansible will automatically push that out to whichever boxes you want to push it out to. Ansible is kind of hidden under the back end. That's what's actually driving the connections to the equipment. It's an industry standard tool. Everyone's kind of using it. There are lots of examples of it in the networking space. It's kind of hidden here, but it's also available should we ever have any need for it. Let's say, for example, you had 6,000 closet switches and somebody told you that the SNMP servers were changing. You could use that to kind of deploy those changes more easily. Just another overview here. Typically today, you create a text file if you're using distool on one of the sandbox machines, and then use distool to push it out, maybe on one of the Bastions or the sandbox or something. In the future, you'll edit a template on GitHub, typically through a web browser, and then you'll push the merge pull button to push it out onto the network. Same thing, you could set up the text file ahead of time, so you can set it up during the day, and then during your maintenance window, push it out to a few devices, push it out to all the devices. You can push it out live as soon as you make the change. So you have just as many options in the future as you have today, except a few more. There will be some hooks for, let's say, review. If there's a change of more than 1,000 lines, maybe you want somebody to review it, or the security filters are changing. That goes to a different group to approve. These sorts of things are possible. So the system we're looking at here is that at some point in the future, about a year from now, we'll be pulling a portion of our configuration from what is essentially the database. So you can think, I go to the database to configure an interface or a BGP session or something like that. That will be merged with what I'm going to show today, this sort of GitHub plain text file. Those will be merged together, and then Ansible will push that out onto the routers. There's likely to be some portion of the config, at least initially, that's not automated. So it just lives on the routers, and the router is the source of truth for that. Eventually, we'll handle all of the configurations on the routers. When I say routers, I mean routers and switches and other networking devices. anything that's out in the field. So we're really, at least in the near term, looking at a future in which we pull some information from these templates, we pull some information from the database, and we send that out to the router to be combined with a little bit of config on the router that's very idiosyncratic to it. Going forward in the future, this sort of unautomated config on the router will disappear at the end state, but we'll have a transition period of a few months. So I want to talk a little bit now about templating the configs. We're going to talk about Jinja. Jinja is a templating language that comes from Python, again, a network-centric sort of programming language. It's used by Ansible quite frequently to create configurations to be pushed out to devices. In this case, we're talking about router configs, but it could really be any sort of text file that you want to push out. Many people use it for DNS records and other sorts of records as well. So I've got this sort of example here. Let's say this is the configuration, and you want to push this out to 1,000 different hosts. But the host name is different on each host. So TP8 is TP9, it's TP10, it's TP11, or whatever. Obviously, the root authentication, we're going to say, is the same or different on each host, or maybe it depends. Maybe the backup router is the same or different on each host, but some of this information, like maybe the name server or the domain name, are going to be the same on every host. So this is kind of one version of one of those 1,000 configuration files we'd like to push out. In Jinja, it would look like this. So you can see we've taken the specifics, TP8, the IP address, the domain name, and we've replaced them with what are essentially variable names, surrounded by double braces. This means replace this with a variable called hostname. So it's going to go through a number of records, essentially database files, and for each one, it's going to localize this little config snippet based on the data from that record, that transaction. So going through 1,000 of these database records or node files, it'll just replace each one, and as it replaces each one, it'll create the real configuration with the real host name and everything in it. When I say data file, data record file, there are many ways to pull your data into Jinja. There are environment variables. You can pull it from kind of a plain text file. So there's lots of ways to kind of create these data records. Here's one for TP8. You could imagine another record for TP9, another one for TP10, and so on. And the Jinja templating will go through and pull those variables from each one and instantiate over and over using that template to create 1,000 different records. And then, obviously, if we extend it, that then get pushed out via Ansible to 1,000 different hosts, and you've updated the name server. The Jinja language has quite a few options available. I'm going to concentrate, though, on just a couple. It can do for loops, so you could run through, let's say, a bunch of interfaces all in a row. It can do if statements, so you can say, if this is the campus edge router, then use this name server. If it is a customer premises router, though, use this other name server. So you have lots of options there. It has variable replacement, as we saw in the previous example, where we can pull data from another source and instantiate it into. It also will do includes. So this is interesting. We can, let's say we have a little bit of radius config for a Juniper router. We can pull that out and put it in a text file called radius config. And then we can reuse that little code snippet in our CPE border config, in our edge border config, in our core router config by just saying include radiusconfig.j2 or something like that. And we can do that as much as we want. So we can create little bitty snippets all over the place that we then pull in through conditionals and so on to create a total config for an edge router, a border router, whatever. We'll go through a couple of examples of these. So on the left, I have this sort of data record, right? PGP, I know what my AS number is, I know what the peers I want to make a connection to are, and I know what the address families are. Over on the right, up at top, you can see a little bit of config snippet for Jinja. You'll note that it's using a brace and a percent to kind of define the control language. So for each peer in BGP peers, and you can see BGP peers, right, in that little data snippet on the left, do neighbor and then peer. And then you end your for loop, and that produces this little snippet of config text down at the bottom. Neighbor 192.0.22, one neighbor 192.0.23. Does that make sense? For each BGP peer, neighbor, whatever. You'll note that there's nothing special here to get it to say neighbor, right? Whatever you type is what the config is going to be. So you could essentially copy an entire Juniper config in and say this is the Chicago config or whatever. And it would just say, okay, you're not doing anything complicated here. It's just a text file. Now it would go. We can make it a little more complicated with, say, an if statement. So in this case, if inet in bgp.af, so again, bgp.af over on the left-hand side, if inet exists, then print out, that's the way I think of it, address family IPv4. So now we have added an IPv4 address family to this. Very simple, again, braces with an if and a percent, and then a percent, or I'm sorry, brace percent end if or brace percent end for. It's very simple. Some more complex example. Again, we've got this large kind of data file on the left, and we're trying to create this configuration here on the right. This is what we want to push. You can imagine that this data from the left is coming from the database or some other source of truth. We want to create the router config on the right to push out to this router. You can see on the left, for each address family in BGP.address family, again, BGP address family, right, a child, do family, address family, so that would be inet or inet VPN in this case, coming from our address families there for 2.3. For each peer in BGP peers, do a neighbor peer. So the Jinja control language on the left has created the configuration on the right by merging it with the data file. Same thing with Cisco. Clearly, all we're doing here is merging a template with some data files to create a text file. You could do anything here. You could create HTML, create DNS records. Doesn't matter, right? You're just creating some sort of text file. No difference between creating an HP ProCurve config or a Junos config or a Cisco IOS or IOX config. It just comes out. And again, a small example of that. You can see how we're doing for each peer in BGP peers, again, kind of rolling through the number of peers that we want to make a neighbor statement to. So I've pulled some configuration files from some examples that we're doing for real backbone routers. This is from a Juniper, so we're doing sort of system configs and chassis configs and routing protocol configs and so on. And you can see, or maybe, you could see if the layout was different. Here we go. So you can see almost the very first line is hostname, inventory hostname short. So we're pulling from the database what the inventory hostname is. In this case, I think it's Chicago RTSW. So it's configuring the router with the hostname pulled dynamically from the database. The rest of it is fairly standard config until we get down to the encrypted password. At this point, we're pulling the root password out. This is being decrypted from a special encryption service that's running. So the passwords aren't stored in plain text or anything. It's decrypted on the fly and then inserted into the config. It's never actually stored anywhere until it's pushed out to the router. And then further down, you can see we're doing the same thing with the radius prefix and the radius key. We're pulling the radius key from the database. We're pulling the radius prefix from our encrypted source, combining them, we get the radius key. You can see that we're doing that for each radius server that we have. So we have multiple radius servers defined. What's special about this is now we know exactly on every router in the network, this config is exactly the same. Somebody didn't drop a line in a copy paste. Somebody didn't copy this from the New York router, which had a different config than the LA router did. It's always exactly the same. The consistency here, beyond the simple effort savings, is what's important. As our friend Mark Rovers would say, this is both efficient and effective, right? If you need to swap out those SNMP servers, it's a lot easier. And in order to ensure that the router configs are consistent, we're not allowing NTP amplification attacks by accident on one box. We can do that with this. A few other options that we have available to us. So the Jinja configs can be commented, so you can explain what you're doing. And comments from the Juniper configs can be embedded in this. So you can include in that text file Juniper comments that'll get passed on to the Juniper router, or you can include comments in the Jinja configs. Similarly, I talked about sort of including templates or child templates. That's just a brace % include in the name of the template. And that shows up wherever. So you could have, for example, include Juniper system.j2, and under that include Juniper chassis.j2, and under that include Juniper groups.j2, kind of breaking out each stanza in the Juniper, its own separate sort of file that makes it easier to edit and work with. So we have a lot of options here. Essentially, as many options as you want, we can replicate with this system. We will probably, as we go forward, talk about some best practices and so on that we'd like to try to engage in. But there's no reason using this that we can't take care of idiosyncratic use case that might come up. If something that needs to be applied here and not here, we have some code that only exists in one place and not another place, we can do all of that with the system. We'll make these slides available, and I'll pause a little bit on this screen as well. The recording will be available also. These three websites are pretty good for both Ansible and Jinja overviews, so you can learn more about Jinja. There's a lot of options that I didn't go into. The ifs and fors and includes, though, are by far kind of the most useful. So you're looking for Jinja or Jinja 2. If you were to Google or look on YouTube for more information about this. Pretty simple. In addition, there is a series of videos on YouTube. Don't laugh. It's called Git and GitHub for Poets. And it really is for poets. But it's kind of an example of using Git and GitHub for text files, right? You think of poetry as kind of a text file. A router config is more like a text file than it is an application that you're going to compile and then run. So the sort of manipulation of text files. From this, you should get a great idea just viewing the first two videos, which are about 20 minutes total, on how to edit a file in GitHub, how to branch and how to merge that branch back into the main config. That'll give you a good introduction for where we're going here in 2 or 3 weeks when we get into the specific workflows, an example of a workflow and how to use GitHub. So just a little bit of background here. I'll pause now. Any questions about this? After this question period, I'm going to run in and maybe show a few real live examples that we have in GitHub.
I'm not familiar with Jinja. Is that like a form of Python or?
So it's a data modeling language, I believe. There's a well-formed sort of, if you're familiar with XSLT, right? In the same way that you might transform XML data through XSLT to create something else, you can use Jinja to take data files and transform it into another format.
Whatever structure you need. Like
another, yeah, whatever you need.
Whatever, yeah. Okay.
Yeah, exactly.
Is there such a thing as exclude? In other words, words, if I want to take everything from this list except something,
From this list.
from a for loop.
Yeah. You can, I mean, you can do logic and stuff in your for loop, right? So you can do, you have to wrap it in for whatever, and then there could be this statement in there, like, if it's equal to this, then ignore it.
An example would be, like I wanted to create a mesh of LSPs, but you're not going to create one to itself, so you want to exclude itself kind of thing.
Yeah. You can reference other things.
I can show you an example of that. We actually have a good example of IBGP meshes, creating IBGP meshes. You want to create a mesh or a neighbor connection to everybody else except yourself, right? So again, you use kind of an if statement to say, if the name is my name, then don't do this, right? Otherwise, create a neighbor statement. Any other questions?
So I have a bit of addition. One of your links, the third one, was to Jason Edelman's blog.
Yes.
He wrote an amazing book for network automation, and I highly recommend it.
So Vadim was saying that the third link here is to Jason Edelman's blog. He wrote a great book on network automation. I would second that. It's kind of what most people start with for network automation. It's a good blog to follow if you're interested in these topics at all. Okay, I'm going to attempt to show a little bit of real configuration work here that we have done. We still have the screen shared, is that correct?
No.
No, okay. Well, let's stop sharing and share again.
All we see is the solstice.
Oh, there we go.
There it is.
There we go. So this is kind of the GitHub interface, and I'm going to use this to sort of navigate around these text files. Okay, so this is similar to the way you will be working in the future. The subdirectories and so on may change, the specific names may change, but the workflow here. So you can see that I am working in an Internet 2 repository up there in the upper left, files related to Internet 2. I'm going to go down here to build conf. This is a directory that contains both variable, node record variables for each node in the record in the database. So all the DWDM nodes, all the fiber distribution panels, all the MFPs, all the out-of-band routers, and eventually we're going to scroll and keep scrolling. By the way, one of the changes we're making is to get rid of all this and make it easier to understand, so you don't have to scroll through all of this. So here's an example of a data record. This is for the Chicago router. You can see how readable it is there on that one line. Super readable there. But if we go over here to raw, we can get kind of a more interesting JSON view of the data. So you can see it's got the serial number. This is all just pulled from the node record in the database. The name of the box, short names and long names, route switch server. You can see the management address, which would be the loopback address of this box, which is clearly extremely important in a config, as you're doing a lot with the loopbacks, right? So we have access to all of these variables. You're going to see us accessing them as like node management address to get the loopback address. And you can see that we have a lot of those. So you can see we have a lot of these. We have one of these node records for each of the route switch nodes, the core routers in the network. It looks just like that. So these are the individual data files that are going to be used in the templates to create the real router config. When we're talking about the real router config, I'm going to start here at this one called rtsw-main. And again, this is just an example, right? We have lots of ways that we can format this stuff. It's just the way I've done it. And you can see I've just got a bunch of include files here, essentially one include file for each of the root level portions of the Juniper config. If I follow that up, I can look at, let's say, the system config. So this would be the system stanza. And you can see I'm setting my password from a variable pool. I'm setting my radius servers from a variable pool. I am setting my NTP server as a loopback address, as its source address. My syslog server as a source address, that's the loopback address, node management address. And then when it gets to Chicago, it pops that data variable in and off it goes. So pretty trivial. Again, this looks mostly like a router config. The big idea here, though, is it will be the exact same thing on every router. No more dropped lines, no more I forgot, no more I copied the config from a different node. It's exactly what our intent is. We can look at something, so let's look at the protocols here. And this is a good example of that sort of exclude statement that we were talking about. Note that we're using the replace command, one of the Juniper commands, to say I want to replace the stanza in the config. In this case, we're replacing group Internet 2. This is the group that controls the IBGP mesh for Internet 2. You can see that we are conditionally pulling in a MD5 key for the IBGP sessions. And then down here, for each node in nodes.rtsw, so for each core router, if the name is not my name, because I'm not going to establish an IBGP peering to myself, then do a neighbor to its loopback address and then stick in its description. And that has built the entire IBGP mesh. Same thing for IPv6. For each node, if the name's not my name, then do a loopback, a neighbor statement to its v6 loopback address. And we're done.
So this might be something you would use if you were bringing up a brand new box?
That's right. So we can talk about ways that you might use this, right? So you could create sort of a templated config or a baseline config that you push out to each node that's new based on its role. This is a new CPE box. This is the starting config for it. This is a new core node. This is the starting config for it. So we can both push out configs or build configurations for new devices, or rebuild configurations for devices already in service, or if the SNMP server changes, push out that change to every box on the network, or a portion of them, right? I think we know that one of our concerns in network engineering is blast radius. So maybe you just want to push it out to one box tonight and the rest of them tomorrow, or half tomorrow and the other half the next day. And those are the sorts of things that we can do with Ansible.
So Grover, this is showing a lot of stuff that we can do, like to populate a whole bunch of routers with a config we want to push out. In one slide, you showed Ansible automatically pulling config from the database and pushing it out, perhaps. Is that something you're looking to do to automate certain activities that are not completely, that an engineer doesn't go out and create the config for? So an example that I see where it might be useful would be, there's been a lot of churn in the network where old cards are being pulled out and migrated elsewhere, new cards are being pulled in, and engineers are forgetting to delete the old interfaces, but there's no longer a card there.
Sure.
So something like the ability to go out and determine that there's no longer a card there, there shouldn't be an interface, kind of thing, or
So
be able to create a report that somebody can say, oh yeah, right, okay, do that, push the button.
So that is absolutely something we can do with this, Ron. And could be one of the projects that we could engage in. I think we're starting with kind of the more static parts of the config, like chassis and system and so on. And we're moving into, later this year, into I need to configure a new BGP peer or a new interface, a new interface in a lag group, or I'm turning up a new customer, so I have a lot of things that need to be added. And as add-on projects to those, you can imagine a project like you're suggesting, which is kind of an audit cleanup sort of thing, right? Keeping the data internally consistent, or rather ensuring that the database model matches what's in the field from a hardware inventory standpoint, is one of our key project points that we're trying to stay up to date on, making sure that the data is consistent across them so they don't get out of sync. And I think that falls right in line with what you were suggesting.
I would argue that it's not even a project, it's just what naturally is going to happen as we move to automation, because eventually it'll be the point where you've got a backbone and you want to, and if somebody moves a card, you'll move, instead of changing the configuration on the device, you'll go in the database and basically edit a circuit and say, instead of it going to XE500, goes to XE600. It's just going to automatically change all that config for you. Move the old stuff, add the new stuff. It'll all be managed from the database. So eventually, we won't even need to think about cleaning up because the system will just do it for us.
So we have a lot of, as AJ is pointing out, we have a lot of options to run, let's say, helper scripts or other things as part of the work we do to check consistency, to ensure that things are operating the way we want. And we shouldn't get into the mindset that we're not logging onto the equipment anymore. Engineers not logging on to the equipment, that's a far, far future thing, decades down the road. We hired engineers because we trust them to do the work on the boxes. This is meant to enable the staff to kind of do more and forget so much about that cleanup work and things that sometimes get dropped. We know we should do it, we're busy, sometimes it gets dropped. This is meant to kind of assist with what we're doing, not take over what we're doing.
Grover, in the examples you were showing, the system part of the config, for example, you were pointing out things like radius servers, addresses getting pulled out of the database, but there was a lot of other information there that was just hard-coded in the Jinja template, like SNMP servers, DNS servers, things like that. Is there a plan to look at additions that need to be additional data that should be stored in the database, so more of it can be database-driven rather than hard-coded in the templates?
Yeah, that's absolutely where we're going, Jeff. So here in this first project, I think we've got 4 or 5 weeks left in the first project. We're looking at adding some sort of network-wide variables, like these are my NTP servers, or these are my SNMP servers, or things like that, so that we pull that dynamically into the configs. As you correctly point out, you can think of it as maybe 2 different ways. You could have the SNMP server hard-coded in the config and just go change the Jinja template and then push it all out. Or the template could pull that dynamically from the database from the SNMP server setting and integrate it in. So we're looking at adding some network-wide variables in this first pass. And I believe the NTP and SNMP servers are a part of that to begin with. Which things get variables in the database, or what the threshold is to get that moved in, I'm not certain we're sure where that kind of line is for inclusion versus hard coding. But we know at the beginning that a lot of what we see, especially in the system stanza, is going to be pulled dynamically from the database. So I think, I had hard coded the SNMP servers. I think we're going to, or the syslog servers. I think we're going to pull that dynamically. So lots and lots of options there. Absolutely.
And there's probably a middle ground too, right? Where you just have a flat file that would have those things in it, where it wouldn't be hard coded in the template, but it also wouldn't have to be in the database.
We already have that flat file defined.
So there's lots of options here. There's lots of ways to accomplish what you want to do. And I would encourage everyone to kind of think about sorts of, these baseline configs or standardized configs, how the equipment you work with every day kind of uses those so that we can take advantage of this to help you out.
Yeah, one thing I was going to say is it strikes me that this is very open, and a lot of the work here is not in understanding Jinja or whatever, but understanding how we're going to use it, like conventions and methods.
I think that's a good statement. It is not the case that we will be enforcing standards upon people. We will never say you need to do your system config this way or you need to do your chassis config or whatever this way. What we're going to do is come by and say, you know, how do you folks do this, and try to help you do it a little better. Maybe as a side project, we all kind of get together and look at best practices for system or chassis, and then you can go back to your home network and say, this is kind of the best practice. Let's see how much of this is relevant to us and implement that. But we're not enforcing standards across the networks or across any of the projects. Essentially what we're saying is you have to have a standard. It doesn't really matter what it is.
That's part of my point, but I was also saying, like, for instance, you had a lot of includes, you're very modular. That is a convention too, right? Deciding to generally work that way and how modular to be, and
right.
There's lots of different ways you could use Jinja templates, and we probably don't want to end up with everybody having their own particular artistic style of Jinja.
That's probably correct. That's right. We'll have a different problem at that point. Any other questions? Well, I'm here. I encourage you to reach out if you have ideas or questions. I'll be swinging by the individual groups to do a more kind of targeted presentation as well here in about a week or 10 days or so. We'll have an overview of GitHub and kind of how to use it. And then eventually we'll start working with you to kind of look at your configs, look at other things where you think this might be useful to you. There's a lot of capabilities here. There are very few limitations. Thanks, everyone. I appreciate you joining, and there will be a recording of this available. We're getting a website set up where you can find them all, and the slides will be available as well.
Thank you.
Have a great day.